Right now, a NASA satellite and its booster rocket traveling at more than 6,000 miles an hour on a collision course with that right there, the moon. No accident. No accident plan. This is a planned mission.
That's right. We're going to be watching it live. Robin Roberts, Diane Sawyer, Sam Champion, all standing by here. And by the way, they are sending tweets out from the rocket, which last said, wow, 10 minutes away from locking into the moon. And we're right, Sam, that it's going to send up a plume of rock, and they think possibly ice, and ice will mean water, which means...
Yeah, that water equals life. So what they want to know is if there was ever water on any kind of moon or planet, and so this is a good place to start.
We want to bring in two wonderful observers with us this morning. Astronaut Buzz Aldrin, who's standing by in Washington. Of course, he was one of the first men to set foot on the moon, Apollo 11. And also joining us, Ryan Owens, who's inside the Johnson Space Center in Houston. Ryan, I'll just start with you. Are we on time? Going to happen soon?
We are on time. We expect we're about, let's say, a minute away, space-time, from this huge impact. And Diane, what an impact it will be. As you said, this rocket weighs as much as an SUV. So we all like the moon. We look at it at night, but we are about to hit it twice with quite the double impact.
And Buzz Aldrin, what are you going to be thinking as that happens? What are you most interested in seeing?
Well, I'm probably going to have to look at a replay because I'm going to be looking at you. But I'm very interested in the resolution of exactly what we've been getting from our satellite detectors to give us a little bit more accurate information as to just what is in the vicinity of the impact area.
Okay, Buzz, we're going to take a moment of silence from all of us and let Mission Control take us right to the moon.
We should be looking for some signs of the impact on the leftmost part of the...
Standing by with mid-infrared changes.
The left side of the shadow, right below the dimpled crater on the larger crater rim.
Flight, this is Science. Make the rate changes. MIR 1, 1 hertz. MIR 2, 0.1 hertz. Over.
Copy, Science. Command Flight. MIR 1 to 1 hertz.
Sending MIR 1 at 1 hertz.
And the science team is directing the flight team to adjust the sampling rate of some of the instruments to fit within the 1 megahertz.
Ready with MIR 2 at 0.1.
The 1 megahertz signal limit.
Go flight. Command Flight. Send MIR 2 0.1 hertz.
MIR 2 0.1 hertz. Sending command.
Flight confirm receipt of command. Over. Copy that, payload.
Ryan Owens, what are you hearing right there from the command post?
We're hearing exactly what you're hearing, Diane, and that is that engineers are trying to figure out a way to make sure we can actually see this impact. It's a little unclear exactly what this thing's going to look like.
Operations Flight, 1 minute to transition.
It may be a little more than what it would look like if you dropped a pebble in a bunch of sand, although as we have seen through that animation, this is going to be 350 tons of rock, and they hope some ice included in that will spray out of that crater once impact is made.
The shepherding spacecraft will be impacting a couple of kilometers away. This is the last minute before the shepherding spacecraft also impacts the surface of the moon, and the last minute of flight.
So they're saying they have about 1 minute left.
And you see we're getting inching closer and closer. It's like, remember when you were in school and they would roll out TV sets in the hall and you'd watch something like this?
The L-Cross mission, as we approach very rapidly the surface of the Cabeus crater.
And they're just making sure they have a good shot of the crater.
Still uncertain what exactly we'll be able to see.
Is that the NASA equivalent of bars and tone?
Transition to DV mode.
Flight.
Payload confirm crater.
NIR 2, OPR change request. NIR 2 to OPR 10. Over.
And Diane, we should point out these are infrared pictures of exactly the same thing we were looking at in that black and white pictures.
Ready? Command flight send November IR2 to OPR 10. Command send.
So Ryan, it has hit, and they have an infrared picture, but I gather that they're still waiting for the next phase, which is the analytical machinery to kick in.
That's right. Let me try to explain this. There's actually two impacts. The one that just happened is the rocket booster. That's the thing that weighs as much as an SUV. That was the initial hit. Behind that, about 4 minutes behind it, is a satellite that is going to read that debris, scan it for any signs of the ice. And then that satellite will also hit in exactly the same spot. So that will be, as we've called it, the double impact.
Copy, science.
What would be important with the thermal is the color. You would get some heat out of an exposure.
Oh, here we see them.
The
Mission accomplished.
At Goldstone just reported a shepherding spacecraft has hit
35.054 seconds.
the shepherding spacecraft has hit the surface of the
So
moon.
Buzz Aldrin, we're watching them in Houston, applauding, obviously relieved that this actually happened. How difficult was this mission? Buzz, can you hear me? It's Diane. Buzz, can you hear me? No, we have lost our connection with Buzz Aldrin. They can get to the moon.
Right.
We lose connection with Buzz Aldrin.
Not only can they get to it, but they could shoot into a crater.
That's right. Well, we will try to get him back later for more reaction. But as we say, first of its kind, we were talking, Sam, about the fact that the moon itself is hit some 50 times a year. I had no idea of this. By impacts similar to this, because it has no atmosphere,
Right.
and therefore everything flying through space just slams into it.
And there were a lot of Twitter questions about will that harm the moon? And again, your point is no, it gets hit all the time by debris. The reason we don't is we have that atmosphere and things get kind of burned up as they get anywhere close to us. But there are all the rocks and things flying around. They're hitting the moon all the time.
And we want to learn from that. We want to learn from that.
And we will. Coming out of this, should have some wonderful
Data.
data to look at.